we are going to discuss different ways of solving system of equations. Now, when you have a system of equations, you have three possible solutions if we're talking about linear equations. The first one is you have one solution, and as you can see, it's just where the two lines cross. And when you solve that algebraically, you would get something that says x equals a number, and that would be your solution. And then you would plug it in to find your y. If you have two parallel lines like this, they never touch, so you would have no solution. And when you solve that algebraically, you would get something that looks like this, where there's no variables anymore. It just has two numbers that are equal to each other, but that don't actually equal each other, and it's not right. That would tell you that there's no solution and you have parallel lines. Now this right here looks like it's just one line, but actually what it is if you have multiple lines on top of one another, then you would have an infinite number of solutions. And when you solve that algebraically, you would get something like this, where again, there's no variables at the end, but you have two things that are equal to each other. And that would tell you that there's an infinite number of solutions that lie in the line. So we're going to talk about three ways of solving. The first way is to graph. So what you would do is you would graph both equations and you find where they intersect to find the solution. So for this we have, the first one is 4x plus 3. So we have our y-intercept at 3, and then we'd go up 4 over 1, down 4 over 1, and draw that line, something like that, pretend it's straight. And then we have this line, negative x minus 2, so we start at negative 2, and go up 1 over 1, up 1 over 1, and connect those. And we can already see they have one solution, and this intersection point right here, which is the point negative 1, negative 1. So that would be the solution to that set of system of equations. Another way to do this is called substitution. You want to solve an equation for a variable and then plug it into the other equation. So we look at these two equations right here, and with this, we already have this second equation is already solved for with the y by itself. If it's not, again, you can maneuver one equation and get it so it's equal to one variable. And then we're going to plug this whole equation in to the y for my other equation and solve. So instead of 9 plus y, we're going to put this whole thing in. So it'll be 9 plus x minus 3 equals 4x. And we're going to solve for x. So on this side, 9 minus 3 is 6. If we subtract the x on this side, this would be 3x. And if we divide, x would equal 2. And that's just our x. So we want to find the actual point. So we need to plug this into either equation is fine to solve for our y. I'm going to use a second equation because we already have y by itself. So this will be y equals 2 minus 3, which would be negative 1. So the point for this one would be 2, negative 1. Our last method is called elimination, or sometimes we'll hear it called addition method. It's when you add variables with the same sign, the same number, and opposite signs, because when you do that, they will cancel out. Now for this one, I decided to do one where you have three variables to kind of see a different example that's a little harder than the other ones. So if we look at this, we can see right now that we have our y's that all have 3's, but some of them have different variables. Now if you don't start off with something like this, you can go ahead and multiply a whole equation by the same number to keep it balanced until you get some variables that have the same number and opposite signs, so they'll cancel out. So when we have three equations, what we want to do is we want to eliminate a variable with two equations to get a new one, and then do the same with another two equations, and then go from there. So I'm going to add these top two equations together because I have negative 3y and 3y, so those will cancel out. So when I add those together, I would get 3x, my y's cancel out, so plus 2z would equal 11. I'm now going to do the same thing with the bottom two equations. I'm going to add them together because my y's will cancel out. So if I add these bottom two equations, I would get 6x, my y's cancel out, minus 2z, and then equals 34. Now I have just a system of two equations. So again, at this point, I can again use the same elimination or addition method because these two both have a 2 with different signs. If they didn't, again, you can manipulate the equations by multiplying straight across to make it so that 2 will eliminate. So if I go ahead and I add these two equations together, I will have 9x. These will cancel out, so that would equal 45. And then I can solve for my x, so x equals 5. So now we have one of our variables. We just have to go ahead and plug it in to solve for the rest. So you have this x, so I'm going to plug it into one of these equations to solve for it, so I can solve for my z next. So I'll pick this first equation. So this would be 3 times 5 plus 2z equals 11. So 15 plus 2z equals 11. So when I subtract 15, I would have 2z equals negative 4. And when I divide, z would equal negative 2. So I now have my x and my z, so I have to solve for my y. So I'm going to go ahead and plug that into just any one of these equations. I'm going to do the first to solve for our y. So if I plug it into the first equation, I will have 5 minus 3y plus 3 times z, which is negative 2, equals negative 4. And then I can go ahead and solve this. So this would be 5 minus 3y minus 6 equals negative 4. I can combine my like terms on this side. So that would be negative 1 minus 3y equals negative 4. If I add 1 to both sides, negative 3y equals negative 3. And then if I divide by negative 3, y would equal 1. So we now have our x, y, and z, and we could write that as an ordered number. So this would be x would be 5, y is 1, and z is negative 2. And that will be the solution to that problem.